The next programming language is COBOL. COBOL. COBOL stands for Common Business Oriented Language. As its name implies, it was designed for business data processing applications. Today, it is the most widely used programming language for business oriented application. Business data processing application deal with storing, retrieving, and processing corporate accounting information, and they automate such functions as inventory control, billing, and payroll. The initial work on the design of COBOL language was started in 1959 in the leadership of retired Navy Commodore and mathematician Grace Hopper. The language specification of COBOL were later worked out in 1959 to 1960 by a committee of the Conference on Data System Language, data CODASIL, known as in brief CODASIL, Committee of the Conference on Data System Language, as a joint effort of computers users, manufacturers, and the United States government. After this committee, after this committee defined the language specification, various manufacturers wrote COBOL compilers for their computer, and ANSI COBOL standard was first published in 1968. CAP ANSI published revised version of this standard in 1974 and 1985, which were known as COBOL 74 and COBOL 85 respectively. As long as these standards are followed, a COBOL program can be run on any computer system with ANSI COBOL compiler. Visual COBOL is an object-oriented version of the language. COBOL language continues to evolve even today. COBOL 2002 is the latest COBOL standard. The COBOL language has the appearance and structure of a business report written in English. As a COBOL program consists of sentences, paragraphs, sections, and divisions. All COBOL programs must have the following divisions. The first is identification division, which specifies the program and its author. Next, second point is environment division, which specifies the computer and the peripherals for compiling and executing the program. The programmer has to rewrite this division if he wants to process the program on different computers. The third one is data division, which specifies the structure and format of the input and output data files. It also specifies the structure and format of all storage locations used to hold intermediate result and other value during processing. The fourth one is procedure division, which contains the sequence of operations that the program has to perform. The nature of COBOL program: with the help of a simple COBOL program to compute and print the sum of given numbers. Notice from the example that COBOL programs are verbose but easy to read. We often refer to COBOL as a self-documenting language. A self-documenting language is a programming language in which if a programmer writes the program, someone reading the program instruction does not require much explanation to understand it. The self-documenting aspect of COBOL is made possible by its following feature. First, it's English-like commands. Second, it's English-like sentence and paragraph structure. Third, it's very generous maximum symbolic field name length of 30 characters. With a field name length of up to 30 characters, a name can clearly identify a field and its purpose. COBOL programs should use meaningful field names so as not to lose the self-documenting feature of the language. So I think you are enjoying my lecture series Learning Computer with Seeing the Natural Sights of Indian Village. Now let's talk. Some vendors have also made available automatic programs generator for COBOL program. This software package can generate 7 to 80% of the code needed in an application program from the application software specification. A programmer has to write only 20 to 30% of the code needed to tie the program elements together and to create a customized problem solution for the application. Use of a COBOL program generator can significantly reduce the time and effort needed to code new COBOL programs. Now, in the line of lecture, now I'd like to talk about the next one program is Basics. CAP Basics, BASIC. Basic stands for Beginners, All Purpose, Symbolic Instruction Code. Beginners All Purpose Symbolic Instruction Code. The Professor John Kemeny and Thomas Coons developed it in 1964 at Dartmouth College in the United States. They had the following objectives for developing a new programming language. First, it should be an interactive language permitting direct communication between the user and computer during the preparation and use of programs. It must be easy for non-science students to learn and use the language. To meet this objective, designer of Basic looks the following approach. First, they designed it to use terminals as the primary input-output interface to computer. Before this, most programmers entered their program and data into computer through either punch cards or paper tape and printed their result on printers. Second, they designed it to use an interpreter as language translator instead of a compiler, as used in Fortran and COBOL, so that programmers could create, run, test, and debug a program in interactive mode. Third, they designed it with very few statement and grammatical rules so that beginner programmers could easily learn and use it. When personal computers were introduced, BASIC was the first high-level language to be implemented on them. Today, BASIC is available in almost all personal computers and even in some pocket calculators. This fact makes it one of the most widely installed computer languages in the world. Though simple and easy to learn, BASIC is quite flexible and reasonably powerful. Programmers can use it for programming both business and scientific applications. User of BASIC range from a school student to scientist, engineer, and business manager. It also used to teach programming concepts to beginners. ANSI standardized a minimal version of BASIC in 1978. However, this standard is so simple that it has been extended to virtually every available BASIC dialect. Today, BASIC has many dialects including Basica, Q Basic, and Visual Basic. Microsoft's Visual Basic supports object-oriented features. All our basics begin. Now let's talk about Pascal. Pascal, this language is named after the famous 17th century French mathematician Blaise Pascal. Professor Nicolas Wirth of the Federal Institute of Technology in Zurich, Switzerland, first developed it in 1971. His main objective was to develop a language that allows beginners to learn good problem solving and programming practices. And for this objective, he developed it based on the concept of structured programming. That is, its design enabled programmers to write complete Pascal programs without the use of any go-to statement, unlike basics where go-to is used extensively for branching. For this, Pascal provides special control statements for selection and looping structure. To make program structured, Pascal programs are composed of blocks. Each blocks of a statement start with a begin statement and end with a end statement. Pascal is widely recognized as a language that encourages programmers to write well-structured modular programs and instills good programming practice in them. Hence, it is recognized as an educational language and is used to teach programming to beginners. ANSI standardized Pascal in 1983. Since then, several dialects of Pascal have been made available on different computer systems. An object-oriented version of Pascal is also available. Pascal is suitable for both scientific and business applications because it has features to manipulate not only numbers but also vectors, matrices, strings of characters, sets, records, files, and lists. Now next in the series, the next programming language is C and C++. Dennis Ritchie and Brian Carnegie developed C language in 1972 at AT&T Bell Laboratories, USA. Their objective was to develop a language having the virtue of a high-level programming language, mainly machine independence, with the efficiency of assembly language. They designed C language to meet this objective by providing following feature in it. First, they developed it as a compiled language, that is, uses compiler as its translator, so that a programmer can easily port C language program to other computers having a C compiler. Second, one major feature of C language is a special data type called pointer. It allows programmers to create a reference type variables for any data type. It reduces the need to keep multiple copies of the same data in the memory and essentially allows direct memory manipulation. This feature allows programmers to access memory addresses directly where variables are stored and to perform bit-level manipulation of data stored in memory or processor register. The third point is that it supports user-defined data type for greater flexibility in programming. The fourth one is it supports modular and structured programming concept. That is, while writing a C program to solve a problem, a programmer can break the problem into smaller tasks and can write or use a function to solve each task. The resulting C program becomes a group of functions linked together to produce the problem solution. It also supports a rich library of functions which programmers can use directly for efficient coding of their applications. The next point is that it is a small and choice, concise language providing only essential features so that a language translator can translate a C language program into an efficient machine language code. Although concise and flexible use of a pointer makes C a very powerful language, they also make it without language to learn and comprehend. Beginners